Welcome everybody to Rabbi Talk every Wednesday night as part of our synagogue Reform Congregation Knesset Israel's attempt to keep us together while we're apart. We have a program that I either speak or host. And tonight, I'm delighted that I'm hosting a good friend and devoted member and leader of our synagogue, Dr. Arnold Meshkoff. As you know, Arnold and Norma have the distinction of both having been president of the congregation. They met at KI, they're both lifers, and despite having both served as president, they're still members and still married. So I want to wish them a great mazel tov on their perseverance and endurance. Arnold, as you know, is a distinguished cardiologist, and at this point, I want to say writer and medical educator as well. I remember a couple of years back when he came to me and said he had an idea about writing a book, and I've written a few books, so we talked about books and publishing, and he dove into the project, and the end result is that he is now completed and ready for release, I believe, a very important book. The main title is Chasing the Widowmaker. And this book is important to me because Arnold and Norma are important to me, and also because I recently had my own cardiological episode. So first I got to read about it, then I got to experience it, and now I get to hear about it. And that will be enough medical knowledge for me. I will leave that to all the doctors here online. Arnold has a special guest with him this evening that I'd like him to introduce. And then Dr. Meshkoff has his own presentation, which will be by PowerPoint. And after that, we'll open it up for some Q&A, and we're all going to learn about the human heart and its challenges and strengths and wonders, because it really is a wondrous organ and is what keeps us alive and beats true. So, Arnold, would you like to introduce your guest, please? Make sure you're unmuted. You have to be unmuted.
That would definitely help. Yeah. So firstly, though, I want to thank Rabbi Sussman for inviting me to speak tonight and giving me an excuse to wear a shirt and tie. So
yeah,
I'm happy that that's happened. But in any case, we all have people who we greatly respect and admire in our lives. Many of them we have not met personally, but one of my heroes, and I don't want to embarrass him, but that's just the way it goes, is Dr. Michael Brown. Dr. Brown, and I'll go into his background, is from this area. I won't give you all the facts right now, but I want to thank him for joining us. Dr. Michael Brown, with his colleague Joseph Goldstein, won the Nobel Prize in Medicine in 1985, and he and Dr. Goldstein still maintain a very, very active research lab into lipids at the University of Texas Southwestern in Dallas, Texas. And it's a great honor to have him join us tonight. So I want to thank Dr. Brown straight away for agreeing to listen to my lecture. He reviewed my book chapter and said the facts were correct. So hopefully I won't make too many mistakes tonight, but I'm sure he'll correct me if need be.
We'll give him the opportunity to do that, Arnold. Don't worry.
All right.
Okay.
In any case, just a brief comment about why I wrote this book, brief comments why I wrote this book. Several years ago, I read a book called The Emperor of All Maladies, a biography of cancer by Siddhartha Mukherjee. And it was an incredibly great book, in my view, detailing the history of this horrible disease and all the scientific twists and turns that have come along the road in the last 100 years. And as I was reading the book, I thought, and I think Dr. Spitz can identify with this, when he and I were in training in the early 1970s, we heard the word widowmaker very often. Widowmaker referred to a specific kind of heart attack that unfortunately afflicted we thought mostly men. We found that we were wrong about that. It affected women as well. And that there was not really a lot that we could do about this. But so much has changed in the last 50 years, where I, as a clinician, am able to prevent heart attacks, to treat people who've had heart attacks so they don't have another one, and also people who have atherosclerosis, to give them medication so that they will not have a heart attack. And I thought the time had come for someone to put together a book describing these great historical advances. And I thought I would call it Chasing the Widowmaker, which I and many of my colleagues had done over the last decades. The history of the heart attack pandemic, and pandemic is an overused word right now, but certainly heart attack has been a pandemic for decades worldwide. So Lance, I want to show our first slide, give some historical context here. Okay.
We're good.
So this is a photograph of one of the most important contributors to the science of medicine in America in the 20th century. And I bet almost none of you recognize this name. This is a photograph of Mary Lasker, who was a woman born in a small town in Wisconsin in 1900. And it came to New York City in the late 1930s, first working as a producer of greeting cards. And she had a successful business. But her life turned upside down when she began to work for an organization called the Birth Control Federation. And I bet some of you can imagine what it's named now. It's Planned Parenthood. And she became obsessed with the idea that the two scourges of human beings, cancer and heart disease, needed to be conquered. And then she married the right man to start down that path. Albert Lasker was a wealthy New York merchant. And when he and Mary married, within a few years, they gave up their professional careers and decided that their destiny in life was to convince the United States government to invest millions and millions of dollars into medical research. So after World War II, Mary gathered a bunch of her close friends, and they became persistent lobbyists on Capitol Hill, pestering legislators and even President Harry Truman. In the true spirit of male chauvinism at the time, Mary and her friends were called Mary and her little lambs. Well, but Mary had a saying: I'm opposed to heart attacks and cancer and strokes the way I'm opposed to sin. I'm going to show the next slide. Okay. In great part due to Mary Lasker's efforts, in 1948, President Harry Truman signed the National Heart Act, which allowed the National Institute of Health to form a separate branch devoted to the study of the disease of blood vessels and the lungs and the heart. As of 2 years ago, the National Institute of Health in Bethesda, Maryland, takes up 300 acres of land with 75 buildings, has 20,000 employees, and a budget of $39 billion a year. And most importantly, it has produced 80 Nobel Prize winners, and I'm sure many more are going to come in years to come. This is certainly a wise investment of taxpayer dollars, and it also changed the entire idea that government should be involved in medical research in a huge way. And it was the National Institute of Health that provided the support of two young physician scientists that unlocked one of the mysteries of medical science and heart disease. Mary and Albert Lasker began the Lasker Foundation, which many people regard as the giver of America's Nobel Prize. And its recent honorees have included Bill and Melinda Gates for their work on public health, and Akira Endo, the Japanese scientist who created the first safe and effective statin medication in the early 1980s. And Dr. Endo is also the subject of another chapter in my book. So I want to give credit to the National Institute of Health and Mary Lasker for advancing medical science in an inestimable way over the last 70 or 80 years. So this is what we're going to talk about a lot today. We all have heard the word cholesterol. This is a chemical schematic of the cholesterol molecule. And it's got 27 carbon atoms and 46 hydrogen atoms and only one lonely oxygen atom. And those of us who studied chemistry and organic chemistry recognize those rings, those hexagon rings, as what we call benzene rings. And they just have a lot of carbon atoms and some complicated chemical bonds with a tremendous amount of energy contained within them. So this is the molecule that causes heart attacks. It was first discovered in gallstones and bile in the 18th century. But it was not until the early 20th century when a very obscure Russian researcher named Nikolai Anichkov in 1912, experiments in rabbits proved that cholesterol wasn't in fact the cause of atherosclerosis. But Anichkov's work was pretty much ignored by the Western world until after World War II, due to world wars and politics and Stalin and communist Russia. But it was finally recognized in the late 1940s. Now, cholesterol is not a bad molecule in and of itself. In fact, it's essential for life. It's an integral part of the walls of the cells of the body, the cell membranes, especially around the nervous system. Cholesterol comes in through the diet, but it's also formed by the liver. This molecule is also the precursors of some pretty important things in our body: vitamin D, cortisol, and testosterone. So we can't live without cholesterol. But cholesterol, by its chemical structure, has a metabolic problem. It doesn't like water. It's similar to why oil and vinegar don't mix. And the human body has a scheme to deal with the fact that cholesterol does not like water. When it comes into the body, it surrounds it with a protein envelope. So in reality, these protein molecules and lipid, of which cholesterol is one, that move around the bloodstream are called lipoproteins. And it was a Jewish physician from Northern California, first trained as a physicist, who was able to isolate the different forms of lipoproteins. And he did it by using a centrifuge machine and spinning down blood tubes. He took the red blood cells out, he spun down the serum, and he was able to isolate levels of different lipoproteins. And this is an example of the kind of thing that John Goffman saw. He saw different layers of molecules. And by being a brilliant chemist, he was able to isolate these molecules and describe them in terms of their molecular weight and their density. This is a photo of John Goffman, MD, PhD. He was first trained as a physicist at Berkeley, worked on the Manhattan Project, and then after World War II, decided he was going to devote his time to medical research. And interestingly enough, his father died of a heart attack. So he was interested in heart disease. Now, I spoke to John Goffman's son a year or so ago. John Goffman is not junior, but John Goffman's son is a retired ophthalmologist in the San Francisco area, and he told me a great deal about his father. He and his father and a dietitian wrote one of the first books advising people to eat low-fat, low-cholesterol diets. And the dietitian and he worked on several recipes. And John Goffman's son told me that his father would have he and his mother eat the recipes to see how they tasted. And he told me that like 90% of the time they were terrible. But regardless, John Goffman was onto something, that it was fat in the diet and lipid and cholesterol in the diet that had a great deal to do with heart disease. So cholesterol, like many of the molecules of life, has a very complex metabolism, which is a series of chemical reactions that leads to its production and breakdown, primarily by the liver. Well, when everything works well, the cholesterol goes to the organs where it needs to go and settle into the membranes of the cells. But what happens when something goes wrong? Well, there are certain people who, because of their genetic tendency, have extremely high levels of cholesterol. And that cholesterol simply has nowhere to go other than into the arteries of the body and sometimes into the skin. And these markers of the skin are called xanthomas. And people who have xanthomas, you can be pretty sure, have a very, very high level of cholesterol. But skin problems are one thing. This is the main problem, is that cholesterol and lipoproteins build up inside the arteries of the body, primarily the arteries of the heart, the brain, the aorta, the big blood vessel in our abdomen, and the blood vessels of the legs. And eventually, this atherosclerosis becomes worse and can interfere with blood supply, causing chest pain when people exert themselves. But the big threat is that a blood clot will form on top of the area of atherosclerosis, completely cutting off the blood supply and causing an acute heart attack, damaging the heart muscle, often irreversibly. So this is the real epidemic that is caused by cholesterol. So in the 1960s, it was pretty well known how cholesterol was metabolized inside of liver cells. But the whole system of how cholesterol and lipoproteins come into the gut and into the bloodstream and into the liver and back out again, those details were really obscure. And this is the milieu that the people I'm going to talk about tonight found themselves in, Dr. Michael Brown and Dr. Joseph Goldstein. Now, they met as internal medicine interns at the Massachusetts General Hospital, which most of you know is the great hospital of Harvard Medical School. And as they were going through their internship and residency, they both realized that they wanted to pursue careers in academic medicine and research. Dr. Goldstein was born in Kingstree, South Carolina. And I looked on the map, it's about 50 miles west of Myrtle Beach, 50 miles north of Charleston, and is best known for the scene of a Revolutionary War battle involving General Francis Marion fighting the British. So that's all I know about Kingstree. But Dr. Goldstein's father owned a clothing store, and he went to college at Washington and Lee University in Western Virginia, and then medical school at the University of Texas Southwestern in Dallas, where he graduated in 1962. Now, Dr. Brown was born in Brooklyn. His father was a textile salesman, and he obtained a job in the Philadelphia area, and they settled in Elkins Park. And as Dr. Brown grew up, he attended this place. Now, many of you in the audience will recognize that this is the entrance to Cheltenham High School. This is a picture from about 1965. I think this building opened in 1959. I think Mike Brown might not have gone to this building, but this is the entrance to Cheltenham High School, and it doesn't look that different today as it looked in 1965. So Cheltenham High School was founded in 1884. And in the 1950s and 1960s, it was consistently rated among the top 5 or 10 academic public high schools in America. Just one brief story about being a Cheltenham High grad. I was on the beach a number of years ago, of course, in Margate, talking to some old friends, some of whom had gone to Cheltenham, and there was another man who hadn't gone to Cheltenham, and he was listening to us talk about Cheltenham, and he says, you know, I went to Addington. He says, we used to kick in football, which was true. But I was pretty quick, I thought. I said, you know what, you're right. But our SAT scores were a lot higher. So this was a high school that sold the New York Times in its lobby every day for a nickel. And 11th and 12th grade English students read Chaucer, Shakespeare, James Joyce, Dostoevsky. And students, including myself, were regular participants in regional and national science competitions. So Dr. Brown, after graduating Cheltenham, was an graduate at the University of Pennsylvania, and then went to medical school at the University of Pennsylvania. So when I emailed him a couple of years ago, I said, hey, you know, our careers are pretty similar, except the fact that I went into clinical medicine and he went on to win the Nobel Prize. But our educational backgrounds were not that dissimilar. So returning to the story of Dr. Goldstein and Brown at the National Institute of Health, most of us assume that almost all the time spent there is in the research lab, and it is. But the people who train there do spend time in a clinic, and these clinics are often occupied by very unfortunate people who are coming there for desperate reasons. No one in their local area has been able to figure out what's wrong with them or how to treat them. Oftentimes, these are unfortunate patients, people with advanced cancer, but there are also people who have strange metabolic diseases. And so one afternoon, Dr. Goldstein was told that he was going to be responsible for the care of two children. They were 6 and 8 years old. And these children had already had heart attacks. Now, many of us might know what our blood cholesterol level is. It's, I'm going to say 150 to 250 in most people. In these unfortunate children, their blood cholesterol level was about 1,000. And so Dr. Goldstein discussed this situation, these cases, with Dr. Brown. And they realized that they really didn't have anything to offer the kids. Their disease was known to be a genetic problem that had nothing to do with their diet. It's called familial hyperlipoproteinemia. And it was first noted in a family in the 1930s in Norway by a physician named Carl Muller. This was the problem that Drs. Brown and Goldstein wanted to attack. Why did these kids have such sky-high levels of cholesterol? What was wrong with their metabolism? But I want to back up a minute again and talk about the fact that Drs. Brown and Goldstein were already standing on the shoulders of giants when they began their scientific journey. It's hard to believe now that even during the great scientific revolution of the Renaissance, begun first by the astronomers Copernicus and Galileo, who proved to the Catholic Church that the Earth was not the center of the universe, the science of medicine remained dormant until the 19th century. As the science, not just of the universe, but electricity, magnetism, and physics saw great advances, medical science remained in the shadows of the Dark Ages. The chemists had a problem. One of the major beliefs in medical science at that time was that even though chemists could figure out the atomic structure of molecules of the bodies of plants and animals and humans, they could not create these molecules in the laboratory. These molecules are called organic molecules, and they all had something in common. They contained carbon atoms. But they believed that the molecules of the body had some unique property, perhaps divinely determined, that made the organic molecules special. And of course, they had no idea what the property was, so they had a name for it. It was called vitalism. But in the 1830s, a German chemist named Wohler finally broke the back of vitalism. By mixing up some chemicals, he was able to synthesize urea, the most common molecule found in the urine, the one that causes the characteristic odor. Wohler's work opened up the door to so many young scientists, now known as organic chemists, to experiment at will and try to uncover the molecular secrets of the human body. So now perhaps you can understand why a course in organic chemistry is necessary for all undergraduate students attempting to gain acceptance into medical school. So it's almost unfathomable, I think, from the modern perspective, to believe that the most eminent philosophers and scientists of the 17th and 18th century found vitalism to be a foundational belief. But I suspect that future generations will also shake their heads at the still too common current belief that burning carbon has no long-term effects on the Earth. So, in addition to organic chemistry, which led to so many discoveries and new molecules, one of them being the nitroglycerin molecule that Alfred Nobel used to invent dynamite and became the first effective medication to relieve the chest pain of atherosclerotic heart arteries. Medical science progressed dramatically by the end of the 19th century, especially with the development of vaccines to treat many but not all infectious diseases, often epidemics caused by invisible creatures called bacteria, also a concept that took a long time for people to accept. Only able to be seen under the microscope, first invented by the Dutchman Antoine van Leeuwenhoek in the 17th century. And I think it's important to note from a historical perspective that the center of all of this research was not the United States of America. There was great research going on in France and Great Britain, but the real center of medical research in the 19th century was Germany. Germany, of course, is a series of city-states that finally came together as one country in 1871 after the Franco-Prussian War. But in addition to organic chemistry and vaccines, the great area of emphasis in medical science was not in therapeutics. It was in the autopsy room. The scientific medical mind correctly understood that if doctors are going to develop successful medications in surgery, physicians needed to much more clearly understand the diseases they were dealing with, rather than randomly trying one compound or another without proof of effectiveness. Now, there was a giant of this world of German science, medical science. His name was Rudolf Virchow. He was called the Pope of Medicine. Using his microscope and dissection skills, he became a world leader in documenting and understanding the damage wrought by human disease, not just heart problems. But by the middle of the 19th century, he was noting a great increase in the frequency of one particular form of disease, first called arteriosclerosis, the deposition of some type of fatty material inside the arteries that was causing heart attacks, strokes, damage to the aorta and the blood vessels of the leg. Now, Virchow, he had a lot of different theories about what caused this destructive blood vessel disease. This disease was not just associated with the accumulation of fatty material, but also calcium deposits and blood clots that he called thrombi, which is the origin of the term thrombosis. But Dr. Virchow, as brilliant as he was, could go no further than his observation and speculations. But returning to the 20th century, 100 years after Virchow had altered the medical world by describing arteriosclerosis, Doctors Brown and Goldstein had a few solid facts to work with. Anichkov had proven that the fatty material inside the arteries is largely the cholesterol molecule, that the cholesterol entered the bloodstream from the diet, and the liver and the molecules were wrapped up like an infant in swaddling clothes, covered by protein molecules. John Goffman had shown that it was one of these particles, the low-density lipoprotein, LDL, that was the major culprit causing atherosclerosis. So the mechanism of cholesterol inside the human liver was mapped out in all its complexity and glory by 1964. Whoop. How come it won't advance? There we go. Okay. So I hope you'll all memorize this by the end of the evening. This is the kind of stuff they show you in biochemistry class in medical school. But look at the lower bottom. There's a green thing that says cholesterol and all this sequence of different chemicals and different changes. And I circled one, and I'm not going to even try and pronounce this. I'm just going to call it HMG-CoA reductase. It's an enzyme, and for tonight's purposes, I'm just going to name it HMG. So Brown and Goldstein, they knew something else that the chemists, now known as biochemists, had discovered. Let's define metabolism. Metabolism is in a kind of an assembly line of a molecule being altered many times by protein molecules called enzymes until the final product is produced. And when you look at these kind of schemes, as I have over the years, I'm just so impressed by the elegance and sophistication of the system that sometimes it makes me think about divine intervention. But that's a topic for another discussion. All the steps of metabolism, how sugar is broken down, as well as how cholesterol is altered inside of liver cells, depend on the work of these specific protein molecules, the enzymes. Now, a detailed study of these molecules revealed that they were able to break up parts of molecules and allow them to reassemble into other forms, but they all worked at different speeds. Some enzymes were just more efficient than others. But in determining the end product of a metabolic path, like cholesterol at the bottom right of the screen, it was the slowest one that determined the quantity of output at the end. When you study biochemistry, you understand that you're only as strong as your weakest link. All metabolic pathways, the breakdown of sugars, proteins, and fats in the diet, as well as the metabolism of hormone molecules like insulin, have what is known as a rate limiting step. And Brown and Goldstein knew the name of that enzyme. And I'm not going to try and pronounce it. I'm just going to call it HMG. So the two young scientists reasoned that if they could figure out exactly how this enzyme worked, what made it work faster and slower, that they could determine the problem with the cells of the two young victims of the genetic disease of familial hyperlipidemia. For certain, they wanted to try and help these unfortunate victims of a disorder determined by their DNA, not by their diet. But people with this severe form of a disease are very rare. They wanted to see if they could also determine what was wrong in the metabolism of cholesterol in millions of other people with much less severe elevations of blood cholesterol, but were also suffering the ravages of atherosclerosis of the heart attack, succumbing to the growing and growing worldwide pandemic of the heart attack. But how do you attack this problem in a research lab? Most cholesterol is metabolized in the liver. But are you going to do liver biopsies to gain samples to look at in the lab? Well, you can, but liver biopsies are dangerous and often painful for the patients, and are now only done for very specific diagnosis and treatment reasons. You would have a hard time convincing volunteers, even patients with a familial disease of cholesterol metabolism, to agree to a liver biopsy so the two young upstarts could fool around in their labs to try to figure out what was wrong with their liver cells. There was, however, another source of cells that had the HMG enzyme, even though in the human body, it was basically inactive. When in 1953, James Watson and Francis Crick discovered the key to the genetic code, the molecule known as deoxyribonucleic acid, DNA, the DNA was contained in each and every cell of the body in its complete form. And this opened the door to the science of growing cells in dishes of metabolites, called Petri dishes, to keep them alive and study them. So the Petri dish, which was invented first by the German scientist Julius Richard, no surprise, Petri, in 1887, have been used for decades to study bacteria. Watson and Crick's discovery, which by the way was a mind experiment conducted in their office using the hard data of others, especially Rosalind Franklin, meant that each and every cell, from the heart to the bone to the skin, had the genetic information available to produce any other kind of molecule under the right circumstances. Now, the human skin contains specific cells known as fibroblasts. And Brown and Goldstein knew that the fibroblasts have been used to study metabolism for some time. And so they thought the skin cells would be their source of material. And in fact, that worked out. The HMG enzyme worked just fine in the skin fibroblast cells of normal people. And this is an example of what still having trouble with this. Wait a minute. This is what skin cultures look like in Petri dishes. So after convincing themselves that the fibroblast cells could be used in their experiments, the real investigation began. By that time, Brown and Goldstein had left the NIH, their research careers joined at the hip, having joined the faculty of the growing major academic medical center in Texas, University of Texas Southwestern in Dallas. And they were convinced initially that the genetic defect in their patients must reside in this HMG enzyme. When they looked at the cells of their sick patients, they quickly found that the level of activity of the HMG enzyme was 50 to 100 times greater than in the normal cells. The sick cells were just making endless supplies of cholesterol and shipping it out of the liver cells bound to protein coverings. Some of it was used normally to make new cell walls and hormones and molecules, but the excess had no place to go. In particularly, the low-density lipoprotein, the LDL, was settling down inside the walls of arteries. And I like the analogy of spackling compound going onto drywall. Now, the body responded to this abnormal invader as a foreigner, setting off a string of events that led to further blockage of an artery and entry of blood platelets. Platelets are the little things that prevent us from bleeding to death when we cut ourselves shaving, and then clotting proteins into that specific area of the artery. The result over time was a myocardial infarction, a heart attack. But let's return a minute to what Brown and Goldstein's first discovery meant. It meant that the HMG enzyme was in violation of one of the fundamental laws of metabolism. What goes up must come down. Our body's metabolism is exquisitely regulated. When we eat carbohydrates or sugar, it passes through the intestine and a signal is sent to the pancreas to have specific cells known as the islets of Langerhans. And I just love that expression. It's very poetic. And of course, the islets of Langerhans were discovered in 1869 by a German pathologist named Paul Langerhans. So the pancreas gets a signal to start making insulin so that the sugar molecules will end up inside the cells. But when the sugar level drops, the insulin production also drops. The pancreas just doesn't keep making insulin out of control. This process is called feedback regulation, or as I like to think about it, the body's thermostat. The thermostat should also control how much cholesterol lipoprotein the liver makes. But in the Brown and Goldstein patients, the thermostat was broken. The excess cholesterol in the blood should have been entering the liver cells, sending the signal to the molecules in the chemical pathway that enough was enough. The HMG enzyme should take a rest. But in the hyperlipidemia patients, the enzyme just kept working, unable to shut itself off. And the LDL cholesterol just kept pouring out of the liver cells. So there must be a genetic defect in the HMG enzyme system. The DNA that produced the protein in the enzyme must be wrong. This was the first and most simple explanation, but it was wrong. Brown and Goldstein were very careful scientists, always skeptical of their results, wanting to demonstrate over and over that their conclusions were correct, and also wanting others to confirm the results in their own laboratories. These beliefs of collaboration and doubt are the foundations for all modern science. Even Albert Einstein wanted others to confirm his theories, and they finally did. Now, Brown and Goldstein had a suspicion that their first conclusion was wrong because they already knew about the biochemistry of cholesterol. Remember, I said cholesterol molecules don't like water. It's the oil to the body's vinegar, which is an oil-based acid. The water in most cells, we are mostly made up of water. But they also knew that molecules, in order to get into cells, and in particular liver cells, needed to pass through the membrane around the cells. Molecules just can't walk into cells unannounced. They need to pass through specific channels in the cell wall, or need to be taken up first by specific molecules on the cell walls. And if you remember one thing that I'm going to teach you tonight, it's the concept of receptor molecules, because it is probably one of the most important concepts in medicine in the last 100 years, more than 100 years. Brown and Goldstein knew that most molecules that mix well with water, like sugar molecules, entered the cells easily through the channels in the cell membrane, like ships passing through the Panama Canal. But other molecules, especially fat molecules that can't mix with water, they need something else. They need to be specifically carried into the cell by a very particular molecule that sits on the cell wall, delivered into the liver cell, just like the driver who places your Amazon Prime package at your doorstep. Now, I want to diverge a minute and talk a little bit about receptor molecules because they're not so intuitive. We owe this most important medical and scientific concept to a German, of course, Jewish, of course, scientist of the 19th century. This is a picture of the great Paul Ehrlich. And I do love this story. And I know Dr. Brown read about this in my book, and even he didn't know this story. Paul Ehrlich was born in 1854, and he's one of the true geniuses of the last millennium. Using a microscope given to him by his older cousin, who was a medical student, Paul Ehrlich began looking at the cotton cells that were exposed to dyes. His family was in the textile business, and they were always looking for new dyes to produce different colors of cloth. Paul quickly noted that some of the dyes stained the walls of the textile cells very deeply, but other dyes just stained it slightly or not at all. Now, poor Ehrlich, in one of the great mind experiments in history, reasoned that cells must have particular molecules embedded in their cell walls that have the specific chemical configuration to bind certain dye molecules, but not others. And he called them receptor molecules. Now, Ehrlich's insight was profound. He did go to medical school and he worked with Robert Koch, and again, the great German microbiologist who discovered the bacteria that causes tuberculosis. Ehrlich was convinced that there were molecules either in nature or produced in the biochemistry lab that could bind to unseen receptors on the walls of not just human cells, but the cells of that great killer of humans, bacteria. And if he could find a molecule that bound to the cell wall of bacteria, perhaps it could enter the bacterial cell, mess up its metabolism, and kill it. He didn't call these molecules he sought antibiotics. That moniker came much later, but that's what he was looking for. And after years of often mind-numbing research, looking for molecules that could attack bacteria, Paul Ehrlich found a molecule called salvarsan in the first decade of the 20th century. Salvarsan was the first effective treatment for the dreaded and widespread disease of syphilis. Salvarsan became known as one of poor Ehrlich's magic bullets and changed medicine forever. Poor Ehrlich died in 1915 at age 61 of a heart attack. In 1940, Warner Brothers released a film named Dr. Ehrlich's Magic Bullet, starring the famous actor Edward G. Robinson. I saw that movie, but it was a long time ago. But returning to the heroes of tonight's story, Brown and Goldstein again stood on the shoulders of a giant. Using elegant science, they proved that the problem in the children and patients who had the familial hyperlipidemia was not the HMG enzyme, but that their cells had many fewer and dysfunctional receptor molecules for the LDL molecule in the blood. There was just no way that enough of their LDL cholesterol molecules could get inside the liver cells to send the signal to shut down the metabolic pathway, therefore resulting in an almost endless supply of more LDL molecules pushed out of the liver cells and ending up with no place to go other than the walls of arteries. The HMG enzyme was just fine, doing what it thought it needed to do in the absence of a molecular signal from cholesterol to slow down and stop it. How did they prove this? They used some clever science, again going back to the knowledge that certain molecules liked water and certain molecules did not. And they combined the LDL cholesterol molecule with a protein called albumin, and they knew that the albumin would get right into the cell and bypass the receptor. And once that albumin LDL combination went into the cell, guess what happened to the HMG enzyme? It shut down. Now, Doctors Brown and Goldstein went on to actually find the actual LDL receptor molecule and characterize it chemically. Their work and the work of many others discovered that there were many people who had a much milder form of familial hyperlipidemia, and that they also had receptor molecules that were fewer in number and didn't work as well, leading to elevated cholesterol blood levels and a much greater chance of a heart attack. So, of course, this is a simple diagram of Brown and Goldstein's discovery. And you can see that on the top, you've got the phospholipid, which is just another way for a name for the lipoprotein that covers the cholesterol. It's approaching the cell wall. The LDL receptor is grabbing onto it, carrying it into the cell, where the cell does its metabolism, resulting in either destruction of the molecule or production of more LDL cholesterol to be released to the circulation in general. But even in those who don't have a genetic problem with their receptor molecules, the key role of the LDL receptor in handling the LDL cholesterol particle was apparent. When we consume too much cholesterol in our diet, we just outstrip the ability of the LDL receptors to grab onto the LDL particles and rid the blood of them. They just float around, getting stuck in the arteries and doing damage. The exact details of metabolism of lipoprotein molecules is extremely complicated and continues to be an active area of research worldwide. But from the view of the doctor caring for the patient, the problem of too much cholesterol is often a combination of genetics and diet. This is a picture I found of Doctors Brown and Goldstein. They were awarded the Nobel Prize of Medicine in 1985, and as I mentioned earlier, have maintained an active research laboratory in Dallas for over 50 years. I spoke to Dr. Brown first in the fall of 2019, appealing to his sense that he and I had similar young backgrounds, and finally got a hold of him, and I asked him to review my book chapters so that I got the facts right. And when we spoke, I said hello and thank you, and his immediate response was, "I recognize your accent. I guess the Elkins Park roots are strong." The end of our conversation concerned the Philadelphia Eagles and his belief that the team should have kept Nick Foles and Carson Wentz. And then I knew he was a very smart guy. The work of Brown and Goldstein helped others develop medication to lower cholesterol, the statin drugs. These drugs do interfere with the action of the HMG enzyme because they are hydrophilic molecules. They like water, and they can get into the cells and bypass that LDL receptor. In recent years, a new form of medication has been developed that actually makes the LDL receptors more effective. They destroy the enzyme that breaks down the LDL receptor every day or so that they last much longer. These medications, which are injected under the skin every 2 weeks, have achieved very dramatic drops in cholesterol levels to levels seen when we were children, even in people who were already taking statin medication. An even newer injectable medication is in the FDA approval process, and if so, that medication needs to be injected just once every 6 months. The Brown and Goldstein story is one of the many great stories about how dedicated scientists changed the world of medicine, doing diligent, often tedious work in the back rooms of medical school buildings, on stained lab tables with bad lighting and often strange odors. I know that Michael Brown owes some of his skills to his years in Elkins Park in Philadelphia. Many of us older CHS grads brag about Reggie Jackson and Benjamin Netanyahu, but I hope I don't embarrass him, but if I do, that's just too bad. My hero is Michael Brown, MD, Nobel Prize winner. Thank you for your attention, and hopefully we can get some comments and questions, and I, again, appreciate the opportunity to speak tonight.
Thank you, Dr. Meshkoff. Thank you so much. You can take the screen down so we can see each other. And Dr. Brown, if you can hear me and you have any initial comments or questions for Dr. Meshkoff, maybe we'll give you first opportunity tonight.
Screen share.
Well, make sure you're unmuted. Thank you. Welcome, and thank you for joining us.
Thank you. Thank you. First of all, let me say to Arnold, I congratulate him on his scholarship. It's obviously a hobby of his to go into this history. He's been seeing the other end of it in patients for his whole career. But at this stage, for him to spend the time and the diligence to delve into this broad history is really a tribute to Arnold. You know, I'm sure he's not doing this to make a fortune in money or to become the Tony Fauci of cholesterol. But I think he's you know, it's just something in some people that just wants them to find out, you know, what's behind everything. And Arnold has done that, and he shared it with his book. And so the first thing I want to say is thank you, Arnold. Of course, what he said about Joe Goldstein and me is very flattering and way in excess. So, so let's forget about that part of his scholarship. But I was thinking about Knesset Israel, and I was remembering that the building, it was built while I was in high school at Cheltenham.
Right.
I remember I graduated in 1958 from Cheltenham High School, and I remember, and of course we were Jewish, but we were conservative, and the Knesset Israel building, I believe, is on Old York Road and it
Yes.
was built while I was in high school because many of my friends' families, and it was considered sort of a futuristic building at the time. And I don't know if it's still there in the same building. Are you guys still in that sort of
Still there, same place.
round building? That's really really amazing. It's just amazing. Of course, we're members of a Reformed congregation here in Dallas. It's a very big congregation. I don't know, 1,600 families or something, but or maybe much more than that. But when we have these kinds of Zoom things, we don't get as many people tuning in as you do. So I think it's a tremendous tribute to your congregation that so many people, unless maybe you're all concerned about your coronary arteries, I don't know, but the fact is that it's a tribute, I think, probably to Arnold and his reputation in your congregation. And I'll say a couple things about, if you don't mind, a couple things about Cheltenham High School. Somebody mentioned Reggie Jackson. And of course, he is the most famous graduate of Cheltenham. And the most infamous one is Benjamin Netanyahu. But the fact is that when the Nobel Prize was announced way back in 1985, the principal of Cheltenham at the time called me, and they had looked at the yearbook from 1958 when I graduated, and it showed that I played baseball, and I was on the baseball team. And so he called and he said, we would like to put a plaque, a bronze plaque on the batting cage that says, this is where Michael Brown, Nobel Prize winner, played baseball. So I said, okay, you can do that under one condition. You have to put a plaque in the chemistry lab. It should say, this is where Reggie Jackson did chemistry. And I thought that would be equally appropriate. But the fact is that I owe a lot to Cheltenham High School. I owe a lot to the community of Elkins Park and the surrounding area. It was certain teachers at Cheltenham High School that really built up my confidence and gave me the confidence to go ahead and embark on a scientific career. So so when Arnold called me, not only did I recognize his accent, but also the connection to the place where I grew up, which is still, the other thing that amazes me is that many of the people that I grew up with are still living there in that area. There are a lot of people who grow up and stay. I don't know, I look at this audience, how many of your children and grandchildren still stay in that same area, but I've been impressed that a number of my high school friends have stayed as Arnold has. So there's something attractive about Elkins Park and the surrounding areas. So
We have really good synagogues.
yes, the Jewish community is very, very strong in that area. It's amazing. Anyway, thank you, Arnold. You know, the work that Joe Goldstein and I have done, as he said, it started with seeing these two little children who had such high cholesterol levels and were having heart attacks in childhood. and the frustration we felt in the this was by that time in the late 1960s, but still there was nothing you could do for them. There was no coronary bypass surgery, there was no angioplasty, there was no heart transplants, there were no medicines to lower cholesterol, and we were watching these two really, really sick children, and we just felt that, you know, if we could figure out what was fundamentally wrong with them, that maybe somehow that knowledge would eventually lead to treatment, and so that was what was driving us, and we were very fortunate that the cause of their disease was something very fundamental, and so it did lead to new treatments, including the statin drugs and other treatments for high blood cholesterol. So anyway, thank you, Arnold. Thank you for inviting me to participate in this evening. Thank you for letting me look at all these young faces
Thank you, Dr.
and reunite with Elkins Park, Pennsylvania. Thank you.
Thank you, Dr. Brown. Thank you for honoring
Thank you so
us
much.
with your presence. I don't know if we had a Nobel Prize winner speak to our Wednesday night group before, but thank you for localizing it, making it so personal. We all deeply appreciate it. Arnold, how do we get your book? We want to read it. We've heard the a short summary of part of it, but there's a lot more in your book. How can members of our congregation obtain your book?
Well, I was hoping you would ask me that question, Rabbi.
Well, you know, I didn't even ask for $20 to ask the question. So how do we do that? How do we help you out?
Well, actually, if you go to Amazon and you know the bar on the top, if you just put in Meshkov and hit enter, the book will appear lower down. You could purchase it in hardback, paperback, or Kindle. It's in pre-publication, but the publication date is rapidly approaching. It's March 31st. And, you know, if you buy it, that'd be great. I think you'll learn a lot more. There are many more chapters. I cover a very broad area of work about atherosclerosis and prevention and stress testing and heart bypass surgery and angioplasty. There are personal stories about patients. The Widowmaker has a voice in the book. And I want to give a shout out to Mary Laforte, who was my editor, is on this call tonight. Mary shepherded me through this 3-year process, and I owe her a tremendous debt of gratitude. So I'm proud of the book. I think people will enjoy it. I think people will learn something. I think that it will empower them. You know, heart disease, we're in an era, of course, a year with COVID, but heart disease is still, unfortunately, the #1 killer in the world. But there's so much that we can do to prevent heart disease and atherosclerosis. And I think if you read this book, it will give you a much deeper understanding of what a cardiologist's mind is like and how we approach these problems and how we can diagnose it, prevent it, and treat it. And I think, unfortunately, we live in an era where too often going to the doctor's office is seeing a nurse practitioner for 10 minutes and a doctor for 3 minutes. And I think this is an opportunity for people to really gain some deep insight into heart disease, the major form of heart disease that causes heart attack. Just one final comment. When I was a kid, and I think many of you will recognize this, I would hear my parents talk about, you know, so-and-so had a coronary. And I had no idea what that was. And I guess my parents didn't tell me until much later that sometimes when people had a, quote, coronary, they did not survive. And so that has so dramatically changed. And I think people need to be empowered, and that empowerment comes from education. So,
Arnold, this
yes.
is Mary. Can I make
Hi.
a comment?
Sure.
Okay. First of all, Norma thinks it's a lie that my camera's broken. My camera is broken. However, I wouldn't be on anyway, Norma, because I haven't been to the beauty shop in about 4 months. But my comment is, I want everyone to know that this is more than just this brilliant scientific work explaining about this pandemic. It reads as a novel. It unfolds as a story. And as I was helping edit, I was mesmerized. Every night, I would take one of the stories to dinner. My son and his wife lived with us when they moved back from Argentina during COVID. And it was okay. They couldn't wait until I would read the latest story we had gotten. And every time they would say, I had no idea. Oh my goodness. So it's not just science. It's not just history. It is really a novel about the miracle that these unbelievably intelligent doesn't cover the word, courageous and creative and curious people did to get us where we are today. And the fact that Arnold could capture all of that in a way that's mesmerizing made my job one of the best projects I had in 30 years.
Oh, what a wonderful thing to say.
Thank you. Thank you.
You're welcome.
Arnold, if you're available, I have 2 comments on chat that I'd like to share with you. The first comes from, and then we can close it up for the evening. First comes from our member, Ellen Plout. And actually, Ellen, if you want to state it yourself, you can just unmute yourself or I can read your comment. What would you like to do?
Hi, actually, Rabbi, it's Jeffrey.
Okay, not as good, but we'll take you. Okay.
I'll relay that to Ellen. Arnold, have you ever heard of Conrad Block by any chance?
I've heard the name. It's Conrad with a K.
That's correct.
He's an author, but I don't know too much beyond that.
Okay, sorry. He won the Nobel Prize for one of the early discoveries related to cholesterol metabolism.
That's where I've heard 1964. That's right.
That is correct. In
Yeah.
1964, he is my uncle's brother. So
Oh, wow.
his brother married a Plout.
How about that?
My Aunt Anne, who just passed away a month ago in her 90s. So just thought of that. Number 2, I have a version of FH, family history of high cholesterol, was treating it for years with statins.
Right.
And did not realize over the time that it was having deleterious side effects, particularly relative to muscles.
Yeah.
And I believe that those side effects are much more common than the public knows about. And as a result, I'm now on Repatha, which is an injectable.
That's the medicine I was talking about, right?
Yeah. And so I guess I wonder to what degree you think statins have these effects in the general population that uses them, especially for those who need high doses and have needed them for a long period of time.
In my experience, and I think this goes along with what the literature says, it's 5 to 10%. The vast majority of people do just fine on statins. There certainly are people who have side effects. There are now 6 FDA-approved statins. Oftentimes changing to another one or a lower dose or an every other day regimen is helpful. But there are new medications, as you pointed out. If there's an injectable one, there's a new oral medication. As I said, there may be an injectable medication that can be used every 6 months. So there are more options. But if you want to chart the decrease in the incidence of death from heart disease in the United States, beginning in 1987, that's exactly when the first statin was released. These are wonderful drugs. They work. They absolutely have side effects, but so does every other drug.
Thank you.
Also, thank you for a wonderful presentation. Thank you.
Last comment from the chat, and then I'll just make a closing remark. And Arnold, you're welcome to make a closing remark too. Our temple librarian, Linda Roth, would you like to ask your own question or do you want me to read it for you?
It's actually Jonathan, her husband.
Oh, boy, all these spouses are switching on us. This is Dr. Jonathan Roth, and you're an anesthesiologist, correct?
Yes, and I've crossed paths professionally with Dr. Meshkov a few times. Anyway, in his diagram, he had this APOB as part of the mechanism. Can you explain what that does?
It's the protein, external protein lining around the cholesterol. So it's part, there are different forms of it. And that's one of the ones that codes the cholesterol in the low density lipoprotein particle.
And what is its function?
Its function is to allow entry into the cells of the cholesterol cocoon, if you will, because the apolipoprotein B is water soluble. It'll attach to the LDL receptor and allow it to enter into the cell.
Okay, thank you.
Good, Arnold. I think you just got recertified on your medical licensing, so thank you for technical answer there. I want to thank you, and I want to thank Norma, because it's a team project, and it's taken a lot of time for you at home. So thank you to both for working on this and bringing it to a successful conclusion. And at the same time, I can let everybody who's a member of the synagogue and our guest tonight know that at no point during this 3-year project of writing a book did Arnold ever let up in his connection to the synagogue, stayed a member of Torah study, and very supportive of every aspect of our congregational life. Dr. Brown, we don't always get 100, but it certainly helped the average. And next 2 weeks, for our Wednesday night rabbi talk, it'll be during the holiday of Passover. So I will be addressing different aspects of the Haggadah. And just like Arnold, there's a good chance I'll historicize those discussions. For those who know me, know everything becomes historical. We have many other programs. We have Shabbat services. Our adult ed runs several programs a week, social justice. There's also volunteer opportunities. We're particularly committed to helping relieve the needs of food insecurity in our community. If you are looking for volunteer opportunities, Synagogue has also just become a mass vaccination site. So if you're over 65, you will qualify, and you can check with our office. If you've not yet had your first shot, you can get that process going. We are a synagogue that from early in its history has stood solidly with science, that science and faith are not only compatible, but they're necessary partners to one another, as has been exhibited tonight. So again, thank you for a wonderful learning evening at very, very high level. And Arnold, I'll give you the last word if you like it. But in the meanwhile, thank you so much for everything you do for KI, and now for teaching the whole public, the whole world. I'm sure your book will go into translation as well.
Well, again, thanks, Rabbi, for inviting me. And again, I want to thank Dr. Brown for being here. And I hope that everybody learned some things. And this is an area of important health information. And we all can do better and protect ourselves and live longer and happier lives. And that's really the goal. So thanks for allowing me to talk.
Great. The Jewish value is called Pikuach Nefesh, the saving of a life. And we certainly saw it tonight at the gold standard. Thank you, everybody. Have a good evening. Stay safe. Keep doing all the right things in terms of public health policy, so that when we can come together, we will all be there. It's very important to play by the rules during this difficult time. Good night, everybody, and happy Passover for those celebrating our holiday. Happy Easter for our Christian guests who are with us this evening. Take care.
Thank you, Arnold. Have a good one. It was wonderful.
Good night.